Yes, a 12/2 UF cable can be placed in the same trench with a 3/4-inch waterline, but there are important considerations to ensure safety and compliance with the National Electrical Code, also known as NEC. According to the National Electrical Code, UF cable can be used for underground installations where its conductors are protected from physical damage. The National Electrical Code does not prohibit burying UF cable with a waterline, provided the cable is properly protected. To ensure the safety of both the cable and the waterline, specific protection measures should be taken. Firstly, consider using a conduit. The UF cable should be placed inside a conduit for added protection from abrasion and impact. Secondly, maintain separation. The cable should be separated from the waterline by at least 6 inches in all directions. Thirdly, avoid contact with sharp objects. Ensure there are no sharp objects or rocks that could damage the cable's insulation. Fourthly, ensure there is ground fault protection. The cable should be connected to a ground fault circuit interrupter, also known as GFCI, for added safety. There are additional considerations as well. The ground fault circuit interrupter should be sized appropriately for the amperage of the circuit. The cable should be buried at a depth of at least 18 inches below grade to prevent damage from heavy equipment or landscaping. The cable and trench should be inspected regularly for any damage or potential hazards. By following these measures, a 12/2 UF cable can be safely installed in the same trench with a 3/4-inch waterline. It is important to emphasize the importance of ground fault circuit interrupters. A ground fault circuit interrupter is a safety device that protects against electrical shock. It works by monitoring the current flowing in a circuit and quickly shutting off the power if it detects a ground fault, which is when electricity leaks out of the intended path and flows to ground. A ground fault circuit interrupter is designed to trip very quickly, typically within a fraction of a second, which can prevent serious injury or death. When selecting a ground fault circuit interrupter, it is important to consider the amperage of the circuit it will be protecting. The ground fault circuit interrupter should be rated for the same amperage as the circuit breaker that protects the circuit. For example, if the circuit breaker is rated for 20 amps, the ground fault circuit interrupter should also be rated for 20 amps. Additionally, the ground fault circuit interrupter should be installed in a readily accessible location. This will allow for easy testing and resetting of the device. It is also important to test the ground fault circuit interrupter regularly, typically once a month, to ensure that it is functioning properly. The test button on the ground fault circuit interrupter can be used to simulate a ground fault and verify that the device trips as expected. Another important aspect of installing UF cable near water lines is the burial depth. The NEC requires that underground cables be buried at a certain depth to protect them from physical damage. For UF cable, the minimum burial depth is typically 18 inches. This means that the top of the cable should be at least 18 inches below the surface of the ground. When digging the trench for the cable, it is important to ensure that the trench is deep enough to meet this requirement. Additionally, the trench should be wide enough to accommodate the cable and any conduit that is being used. It is also important to consider the type of soil in the area. If the soil is rocky or contains sharp objects, it may be necessary to provide additional protection for the cable, such as a layer of sand or gravel. This will help to prevent the cable from being damaged by the rocks or sharp objects. In addition to the burial depth, it is also important to consider the location of the cable in relation to other underground utilities, such as gas lines, sewer lines, and other electrical cables. The NEC requires that there be a certain amount of separation between these utilities to prevent them from interfering with each other. It is important to contact the local utility companies before digging to determine the location of any underground utilities in the area. This will help to prevent damage to these utilities and ensure that the installation is safe and compliant with the NEC. When installing UF cable, it is also important to use the correct type of connectors and fittings. The connectors and fittings should be rated for underground use and should be compatible with the type of cable being used. It is also important to ensure that the connectors and fittings are properly installed to prevent moisture from entering the cable. Moisture can damage the cable and cause it to fail. In addition to the technical aspects of installing UF cable, it is also important to consider the safety aspects. Working with electricity can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. A qualified electrician will have the knowledge and experience to install the cable safely and correctly. They will also be familiar with the NEC and other applicable codes and regulations. When inspecting the cable and trench regularly, look for any signs of damage or potential hazard. This includes things like cuts or abrasions on the cable, loose connections, and signs of water damage. If any damage is found, it should be repaired immediately to prevent further damage or potential hazards. In addition to visual inspections, it is also a good idea to test the cable periodically to ensure that it is functioning properly. This can be done using a multimeter or other testing equipment. If the cable is not functioning properly, it should be replaced. When working with underground cables, it is also important to be aware of the potential for underground hazards, such as gas leaks and chemical spills. If you suspect that there may be an underground hazard in the area, evacuate the area immediately and contact the appropriate authorities. It is also important to keep the area around the cable clear of debris and vegetation. This will help to prevent damage to the cable and make it easier to inspect. Regularly mowing the grass and trimming bushes and trees in the area can help to keep the area clear. Finally, it is important to document the installation of the UF cable. This includes things like the location of the cable, the depth of the burial, and the type of connectors and fittings used. This information can be helpful for future maintenance and repairs. It is also a good idea to take pictures of the installation before backfilling the trench. This can provide a visual record of the installation and make it easier to locate the cable in the future. By following these guidelines, you can safely and effectively install UF cable near water lines. Remember to always prioritize safety and to consult with a qualified electrician if you have any questions or concerns. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other professional before undertaking any electrical work. Understanding the National Electrical Code is crucial for ensuring electrical safety. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect the latest technological advancements and safety practices. Familiarizing oneself with the NEC can help to prevent electrical hazards and ensure that electrical installations are safe and compliant. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. When installing electrical wiring or equipment, it is important to follow the NEC to ensure that the installation is safe and compliant. The NEC is not a law, but it is widely adopted by state and local government. Many jurisdictions require that electrical installations be inspected and approved to ensure that they meet the NEC requirements. Compliance with the NEC is essential for obtaining permits and ensuring that electrical installations are safe and reliable. In addition to the NEC, there may be other applicable codes and regulations that must be followed. These may include local building codes, fire codes, and environmental regulations. It is important to be aware of all applicable codes and regulations before undertaking any electrical work. Consulting with a qualified electrician or other professional can help to ensure that the installation is compliant with all applicable codes and regulations. Proper grounding is another essential aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. The NEC requires that all electrical systems be properly grounded. Grounding is typically achieved by connecting the electrical system to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode should be installed in accordance with the NEC requirements. It is important to ensure that the grounding electrode is properly connected to the electrical system. A loose or corroded connection can prevent the grounding system from functioning properly. Regular inspections of the grounding system can help to identify and correct any problems. Overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices work by interrupting the flow of current when it exceeds a certain level. The NEC requires that all electrical circuits be protected by overcurrent protection devices. The overcurrent protection devices should be sized appropriately for the circuit they are protecting. A circuit breaker or fuse that is too large will not provide adequate protection, while a device that is too small will trip unnecessarily. It is important to consult with a qualified electrician to determine the appropriate size of overcurrent protection devices for a particular circuit. Regular testing of overcurrent protection devices can help to ensure that they are functioning properly. Circuit breakers can be tested using a circuit breaker tester, while fuses can be inspected visually to ensure that they are not blown. If an overcurrent protection device is not functioning properly, it should be replaced immediately. Electrical safety is a shared responsibility. Everyone who works with electricity should be aware of the potential hazards and take precautions to protect themselves and others. By following the NEC and other applicable codes and regulations, and by practicing safe work habits, it is possible to prevent electrical accidents and injuries. Remember that electrical work can be dangerous. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. A qualified electrician will have the knowledge and experience to install electrical wiring and equipment safely and correctly. They will also be familiar with the NEC and other applicable codes and regulations.